Welcome back. This time we've got Cupid's crossbow. We made a ballista, a crossbow on a stand that shoots Cupid's arrow, and it also shoots Nerf darts. It's PLA, fully 3D printed as usual, no support. We'll go through some of the design stuff, how to set it up on the print bed and print it, and then how to assemble it. Let's look at the design of this crossbow. We've got these two limbs that we're going to bend. So as this shuttle moves to the back, we're going to pivot here, pivot here. This is going to bend and store a bunch of energy. When we get to the back, we're going to make contact here, and then this angled surface will rotate this out of the way till we get to the back. And then, because this thing's center of gravity is over here, gravity will rotate it into place. And now when you let go, you're hooked. So the limbs are bent. They're trying to go back to straight, and we're hooked on our trigger. So when we pull the trigger and we move this hook out of the way, this thing comes flying forward. It stops at the end because these arms hit this wall right here, and that stops the shuttle. And then the arrow or the Nerf dart just keeps on going. And if you give it a nice uphill launch angle, it'll go pretty far. In the base, we have this diameter into the heart-shaped base, and we've got this little pressed-in knob so that at the bottom we make point contact and we don't have friction fighting us. This guy snaps around the body. So there's these octagonal posts on either side, and then half of this goes over each post. And then there's a post in the middle to hold them together. And we rotate on this full radius down the bottom, and well, we pivot on this full radius, and we can have this kind of rotation, and then we can rotate the bottom so that we can twist on this axis. And that will let us aim wherever we want. So we're going to point this where we want to go, give it enough elevation, and that's how you'll control distance. This carriage, or shuttle, is held in place by this cover, and it holds down these arms. And at first, that was the full containment, and when you tried to pull back on it, this thing basically did a wheelie, and the front came up. So we changed it, and we put this channel in here that the cover locks into as a front support, so that when you pull it back, it really can only go in a straight line, and it works much better. At assembly, we'll look at how this has to bend to get into that slot. It's not so bad, but it was hard to do. We need pivots here and here. This piece is just in tension, and we want the cylinders to rotate here. And we've set these gaps so that we get enough wrap around it so that we actually do pivot and we don't interfere with anything moving. So the ends of this will never hit this arm, and the end of this would never hit the limb and interfere with it. These knobs are just so that the limb can't move and it is forced to bend. So these huge, almost a diameter, but this large radius bulb is what's holding it in place. We bend against it. So we're going to see bending down the entire length of this arm on both sides. And that's where all of our energy comes from. So these get pulled back, and then when these are free to release their energy, when we disengage the hook, this thing just goes flying forward. We've got these arrows that fit into a rectangular channel at the bottom, but we can also fit a Nerf dart in here really nicely. So the Nerf dart will just sit in this V and still sit against the back plate, and it'll launch just like an arrow, but they're a little softer. So if you've got Nerf darts, this is a cool way to shoot them too. Here's the print bed setup. We needed 2 separate prints to get all the parts done. Some of them just take up a lot of real estate. They really don't take that long to print. We'll start with this guy, the arrow shuttle thing. It's going to print right side up. All of this is 45 degrees or so. We could print the overhangs. So this will print without support. The heart-shaped base, just this socket wants to face up. That's an easy part. These guys, the pivot is part of the base. We want to face the socket and the post up. The base prints just like this, normal orientation. We want the slots up, all the holes up. These posts are octagonal so that we can print these 45s without any support and then create that shape so that we have a good interface in that direction. The cover, we're going to face the posts up, and we've got some divots in them this time, which will hopefully make it easier to press down. We won't have to force as much material out of the way, so only the high points will be an interference, and it just should make it much easier to get it all the way home. So we've relieved the corners on the front posts too, in an attempt to do the same thing and just have less interference and make them easier to press together. The second plate, the limbs print on their sides just like this, and that'll give us the strength because we'll have continuous printed lines following this curve, and that's the way that we want it because our bending strength is going to come from the outside, the surfaces that are in tension, I guess, and compression. But we want these lines to be in their strongest orientation, and this is it. This guy's a little post for the bottom of the stand to rotate on. So we're going to face him with the full radius side up. The arrow prints just like this. The the kind of feathers in the back are going to be able to print an overhang. So those are cool. The trigger's on its side, just like this. That'll give us nice smooth surfaces on this and a perfectly round hole. Our normal hexagonal pin that we could print on the side, again, overhangs, strong pin. The fibers that it prints will be strong in this direction. And that's the way that we need it for this guy. And then the linkages, we want to face these radial cuts up so that they're nice and smooth and they can pivot on this knob and the knob on the carriage. And that's it. So face your parts like this, print them on, we use 0.12 layer height, 3 walls so that we get good strong limbs. It's all PLA. The limbs are going to fatigue in time, so plan on printing extras if you're going to shoot this a lot. Here are the parts we should have printed. We're going to start with this base piece and put the limbs on. So we're looking at these guys. They're reversible, and we're going to drop them down into these holes and push them down. They should not be a very tight fit. That's what we're going to bend against for these limbs. Now this part is tricky. We put this tab in the slot this way and turn 90 degrees. Then you kind of bend these around. This is the only part that you have to do it, but it's going to click in and then you're in the rail. The reason for this is when I was only captured on this arm, when you went to cock it, it just rocked backwards. So we made the cover lock into this slot, and now it will move in a straight line like we need. So this guy drops right on to the base. We're going to push down these pegs in the front first, and then the ones in the back. So get them pushed down tight, and this should move nice and freely. We've got the trigger next. So this goes in from the bottom, and we're going to line them up with this hexagon hole. And then we've got to push a pin through. This is a tight fit on the hexagons, and it's loose in the hole so that the trigger can pivot freely. We want it to fall down like this under gravity because that's how it works. And then as this comes back, it's going to move it down, and then it's going to catch. And then when we move it, it'll fire. Now we need linkages to the limbs. So these guys go on like so. And now we have to bend the limb, and you can go from over or under with this. And you want the top of this to be flush with the red knob. So this is the crossbow. By itself, this will work. You can cock this, and then if you push this lever up, it's gonna fire. We've got a stand. We've got this little nub, so we won't have any friction on the bottom. That's gonna fit down in this hole. So this is the pivot, and then we've got to put this guy on. These notches interface with these knobs. Left and right doesn't matter. It needs to point straight down. And then when you line this one up, there's a post in the middle that's you're going to press together at the same time. Now this drops into here. There's 2 different angles in here, so you want it to point towards the more vertical wall. So it should go in this way. And you can tell because you want it to lean back like this so that you have a lot of elevation. And now you can pivot on that white post that went over the knobs, this guy, and you can pivot this way so you can aim wherever you want. The last thing is you cock it, then you can drop in this little arrow, push it all the way to the back, aim, and hit a whole bunch of stands. But your other option is a Nerf dart. It sits in like this.